Welcome to the Ex Terra Podcast. The Ex Terra mission is to explore and discuss the business of space and its effect on the national and global economy, as well as life on Earth. How does what happens in space affect your life every day? That's what we're exploring on the Ex Terra website, as well as on this podcast. Enhancing digital engineering capabilities is a key initiative in space and defense community, allowing efficient access and integration of data into actionable information. My guest on the podcast this time is Eric Spittle. He's the Chief Technology and Innovation Officer at LinQuest Corporation. Eric, thanks for joining us.
Tom, thanks for having me. I'm very honored to be here.
Tell us, first of all, a little bit about what LinQuest does and what are digital engineering capabilities.
Sure, thanks. Well, LinQuest is an industry leader in systems engineering and integration. Predominantly, we work in the national security space market, and we have decades of experience spanning space, ground control, and user segments. With regard to digital engineering, we'll talk a lot about that. It's really a core of the LinQuest capabilities, and we've been growing it over many years. And there's lots of different dimensions to it, and I hope we can get into all of them through our conversation today.
We'll make that a plan, Eric. But first of all, tell us a little bit about your background.
Well, I've been with LinQuest almost 6 years now, and I've been the Chief Technology Officer most of that time. And in the past year, we reorganized predominantly because of the challenges that our customers facing, the need to go faster and to innovate more. We created the LinQuest Innovation Center, and that is now part of my organization. And so we rebranded myself as the Chief Technology and Innovation Officer to match our Space Force customers' leadership titles. It's also a profit and loss center, so we're not an overhead organization. We have direct customers. Another part of our charter, which I think is a bit unique, is we actually look at our other lines of business as customers as well. So we're providing support directly to them in terms of technology transition, staff augmentation. And what we're finding, Tom, is that this is really helping to accelerate our technology transition and ability to communicate innovation across the company much faster by having more folks work on more projects for shorter duration and then to continue to move around within their networks. And that's also helping our customers directly, and we're seeing a lot of benefits.
Were you one of those people who kind of had an interest in space from a young age, like a lot of like I did, and a lot of the folks who will be tuning into this podcast?
Absolutely. I certainly did. I grew up in a military family. My father was Air Force, so I ended up going in the Air Force, did the engineering route, research and development. And long before the Space Force, I was able to focus more on the space side of the Air Force, spending most of my career there, everything from launch to long-term planning to various acquisitions, and completed my career and then actually went to work for the better part of a decade in commercial space manufacturing. And long before commercial space was in vogue within the Department of Defense markets, I was an early advocate, along with many other voices, to try to help dissuade some of the misperceptions of the early space capabilities. And I'm happy we've made some success. And it's really been a transition to LinQuest that's helped a larger platform for that voice, if you will, being so involved in the national security space market. And with commercial getting such great traction now, it's a great place to be. And I think my background is really queued up well for what we're doing.
It's interesting that you said you were in the space aspect of the Air Force. How has the Defense Department changed in its approach to space now that it has a Space Force as opposed to being just a part of the Air Force?
It really has raised the level, obviously, not only militarily with additional general officers, but like the Department of the Navy with the Marine Corps, there is a separate department, and there's universal recognition, I believe, within the executive branch and all of the Pentagon, the importance of space. Every branch recognizes the dependence upon space, and that's critically important. And I think in the commercial context, the average person may not appreciate how much services they're getting every day from space capabilities. But if they really knew it, they would have an even greater appreciation themselves, I believe.
Anytime somebody turns on their phone, calls up a map and tries to get directions somewhere, they're using space.
Absolutely. And how many people actually know that day to day? And so that's part of the good part of it's so ubiquitous you don't realize it, but it's fascinating everything we use it for every day.
Let's talk for a minute about space domain awareness, because it's getting pretty crowded up there. And people think about space as being this unlimited place where there's plenty of room for everybody, but that's not necessarily the case. So we're all talking about space domain awareness. It's a lot more complex. How important is data acquisition, analysis, and visualization to space operators?
It's critically important, Tom. As you mentioned, it's getting more crowded. There are a lot more satellites up there. And it's not just the physical space. Most of those constellations being launched now in large numbers are using radio frequency spectrum. So there's a lot of congestion, in some cases contention or jamming as associated with the larger numbers. And that's a big challenge that the Federal Communications Commission is always working on. So knowing what's going on, both the physical location of where the satellites are and where they're going, as well as what they're broadcasting, is critically important to operators. And the Space Force provides that service. And LinQuest is a big part of that. We're controlling a number of aspects of how that is working. We're spending research and development dollars to help understand that, because it is becoming more and more critical, not only from the services that are being provided, but the challenge of what's happening. There are also natural phenomena such as solar events that cause interruptions, and it's critically important to understand if it's a natural event or is it something that may be nefarious from an adversary. There's a lot of saber rattling that you read about in the press also, and that isn't very helpful. And that is just another dimension of the challenge that space operators have. So one of the things that we have developed is a space battle management training, modeling, and simulation capability to help entry-level guardians and those who are learning to be space operators about space and how it operates. But as again, we go back into more of the broader digital engineering conversation, that tool isn't just pigeonholed just for basic training. It can be used for a lot of other capabilities, and that's part of the larger digital engineering ecosystem that is really emerging across the across industry right now.
I'm sure a lot of people were a little surprised when the FCC recently talked about deorbiting satellites and thought, well, what in the world does the FCC have to do with deorbiting satellites? But it is all about that frequency allocation and making sure that that GPS signal that gets to your phone gets to your phone.
Absolutely. Exactly. There's a limited real estate, limited amount of spectrum, and making sure that it's available for as many users as possible is appropriate. And that's why sharing is so appropriate. And you see a lot of industry companies who otherwise may be competitors are recognizing that and coming together to try to find ways themselves to help solve some of that problem, to make more use out of the spectrum that's emerging, both in space as well as terrestrially, with the additional auctioning of spectrum for 5G utilization. The ability to use that spectrum is becoming more and more challenged and more precious, but all the more reason why we want to use it effectively.
I recall back when there was a big to-do over the S-band when satellite radio was first not only coming online, but then mergers and what the interference on that might have been. I think that was with GPS, that they were concerned about the S-band with what is now Sirius XM. And those are the kinds of things that people don't really think about when they think about satellites and how they get their entertainment.
No, they don't. You just anticipate it's going to be there, just like the old days. You pick up a phone, you expect the dial tone to be there. And that's the challenge, both from a commercial company providing a service to generate the revenue, as well as from a military perspective that deployed troops want to make sure that they're getting the services that space is providing, and they need to have it even on a very bad day.
You mentioned nefarious operators who might try to interfere with satellite communications or Earth observation or things of that nature. And in fact, we all heard the recent news reports about Russia trying to defeat the Starlink capabilities that Ukraine has been using in their conflict with Russia, which points to security in space. It's really very, very necessary now. So how does a company like LinQuest mitigate those security threats?
We're certainly involved in trying to help. One of the things that LinQuest, works on the entire life cycle, everything from policy guidance, which, is continually evolving, that we're collaborating with our government customers, all the way through operations in every part of the life cycle of a system in between. And whether it's cybersecurity or the spectrum protection or just launch protection, those are all aspects of the operation of space systems, which are critically important and need to be able to be effective, whether it's operating nominally or not. And I'm glad to see that more commercial companies are recognizing the need for it as well, both because of government or military interest in some of their services, but also the demand of some of their own commercial markets, like the banking industry. They're certainly driving requirements for security as well. And any RF signature has more vulnerability than even a fixed wire, just because of the openness of the signal to interference or jamming. And it's a challenge that has to continually be addressed. And it's ways in which we can continue to discuss through the Q&A of how LinQuest is helping.
We hear a lot about, and again, we go back to the security issue about an EM pulse. And that's going to be, if someone were to unleash an EM pulse in the region of some of our satellites in space, that it could really literally crash the entire economy here in the United States and perhaps worldwide. How likely a scenario do you think that is? Is that something that people that a foreign operator might risk to bring down a worldwide economy through an EM pulse?
I really don't think I'm knowledgeable on that question to really give a good answer, but I would certainly hope that nobody feels that that's an appropriate action to take, because the ramifications would be so long lasting, just like a kinetic attack, congesting the LEO orbit. It isn't going to help anybody, and it's going to be so detrimental, and it's going to take so long to clean up that I just hope it never happens.
One of the problems with secure systems can be a loss of interoperability and data sharing. Is a company like LinQuest, is your company able to mitigate those issues as well?
We're certainly working in that area. Again, a lot of the questions you're asking are so interrelated, which is fascinating. And, we're looking at different aspects of this, both from the digital aspect, from modeling and simulation and analysis, but also from the experimental. We have a laboratory here in Herndon, Virginia, where I'm located. It's actually down the street in Chantilly, Virginia, where we do a lot of this RF work, both from emulating satellite systems to wide area networks on the ground to cellular networks and 5G virtualized core and radio access networks, to we looking at these kinds of challenges. And to your previous question, if part of the network goes down for whatever reason, whether it's space or terrestrial, not only commercially, but our defense customers really need to make sure that they have access to those services, particularly in a JADC2, Joint Domain Command and Control, or Project Convergence, or Overmatch, whatever service name they want to choose. It's the resiliency aspect of keeping those services providing some level of operability, as well as responsiveness and restoration of the services when they're attacked, is critically important. And those are areas in which LinQuest is very, very involved, both with our customers and our own internal research as well.
I'm talking with Eric Spittle, Chief Technology and Innovation Officer of LinQuest Corporation, on the Ex Terra Podcast. Take a moment right now and click on subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. Eric, let's talk for just a minute about LinQuest's 5G over SATCOM capabilities. Tell us a little bit about that.
Sure, Tom. I was just referring to what we call Link Lab, affectionately, in Chantilly, Virginia. It's an actual physical lab, and we have an anechoic chamber, so we can actually do over-the-air testing without worrying about FCC approval. We're able to control the RF environment in that situation. We have a satellite emulation capability, so we can replicate LEO, MEO, GEO constellations of satellites and the RF linkage in between them. We can do wide area network testing. We have a complete 5G radio access network and virtualized core. We have a cybersecurity suite, so we can do what we call sandbox cyber penetration testing. So we can simulate what these attacks would be against these networks, and other capabilities, including some high performance computing clusters. So we're working with industry partners, with government customers on specific problems associated with large scale constellations. And it's really important in terms of 5G over SATCOM to be able to get some empirical data. Most of the time, what you're hearing in the press are want to be capabilities of the next generation of satellites, whether it's Starlink and T-Mobile's announcement, or some of the other ones, Apple, talking about Globalstar. But there are some startup companies who have some initial capabilities. Well, we're engaged with some of them in the ability to sort of forward look of what the capabilities of the constellations can be over time. And that's really what's exciting. And that's another dimension of digital engineering, which is sort of your theme today, of collecting some empirical data, but then being able to populate it into modeling and simulation to replicate the full constellation of capabilities, what we like to call as sort of the beta experience. So in advance of having that full constellation, you really get a sense of what the capability will be. And when you can augment that with larger models of other capabilities of existing systems and services, then you start to get the additive effect. And that's particularly important in something like this JADC2 scenario, where we want to have everything connected to everything.
How are you using machine learning and artificial intelligence in those solutions?
Well, specifically in that scenario, we actually are developing some machine learning algorithms under independent research and development funding to be able to, in a very complex large node network, dynamically reallocate the links, if you will. And link in this case is either a hard line or an RF signal to a satellite or to other devices in real time, to be able to adjust to respond to outages, to respond to jamming or cyber attacks, and again, to continue to provide some sort of service and or restore the service as quickly as possible. But that's just one specific example. In the larger context, we do a lot of machine learning and data science, but I'd really step back to the how we do it, and it's really about our people. We have data scientists, and data scientists are typically very strong in software, mathematics, and statistics. But we also have a good bench of operations research analysts, and they're schooled predominantly in the engineering sciences and bring a lot of tools. It's the confluence of both of those, not only the tools and the models, but the people with those backgrounds for us and how we approach our data analytics. So coupling that with other mod sim capability or model-based systems engineering really gives us a large spectrum of capabilities from end to end, what we like to refer to as a digital thread, the ability to link data across the entire spectrum through various models is really the key to effective digital engineering integration.
Are you bullish when you talk about your people and the people that are working on very specific, very high level things? Are you bullish on the young people who are coming out of colleges and universities with good STEM education to be able to handle what's coming in the future?
I am. And I think part of it is one of the ways in which LinQuest handles it. Again, back to the folks that we have. I mean, these are real experts and doing phenomenal work, and all of the key analysis centers across a lot of the services, particularly in the Space Force and the Air Force. And we have a very strong internship program, and we have had tremendous response to openings for interns. We've had great success with interns coming out of school. And what we're able to provide in many cases is real hands-on experience. We have a number of interns that have worked in the lab that I've been referring to give them a lot more hands-on experience than the book knowledge that they're able to get. In many cases, they're able to support our customers directly to really understand what it's like to be in our mission space and work with these kind of customers. And the challenge of the problems that we're facing, I think, really stimulates them. And we're finding great success. And so many of our interns want to continue to work with us, and we've had a good ability of retaining them as employees longer term. So I think it's working for us and hopefully for others as well.
I want to go back to the machine learning and AI for just a moment and talk about that capability being helpful in your model-based systems engineering approach. And then if you'd tell us a little bit more about that model-based systems engineering approach.
Sure, Tom. Again, we look at a problem not with the tool in mind. And I think that's one of the nice things, again, about the people that we have with the experience They understand the missions they're working in. In many cases, we have folks who have been in the government or been in the military and understand that mission intimately. So they bring firsthand knowledge of the problem. And that's really one of the key focuses. Then they bring obviously a lot of knowledge within their head, what they've been trained on, what they've done as a data science or operations research analyst or engineer, software developer, whatever it is. And then it's the suite of tools that we start to look at. They dissect and try to figure out what tool is the right one to solve this particular problem. And we don't come at a problem of, we have a hammer in search of a nail. It's really, we bring the whole toolbox and figure out what we need to do. And in some cases, part of what my job is we need to modify a tool because we don't actually have something. We don't know of a tool that actually is going to solve this particular problem. So we'll find ways of stitching a couple tools together or modifying a different tool. And that's one of the things that I think is most interesting and kind of keeps us at the forefront of the ability to be effective here. And again, as I mentioned before, Tom, it's the ability to digitally hold the data in a single authoritative source of truth among these models. And that's where some of the model-based systems engineering comes from. As the name implies, it's model-based, it's systems engineering. Systems engineering has been around for a very long time. Building it into models or doing it as digital engineering are just bringing computer resources to do things that engineers were doing before, just with slide rules and calculators and paper and pen. Now we're really, with the advent of cloud computing, have the ability to much more seamlessly pass data across people geographically separated and across other models. And the digital thread topic I keep coming back to is really instrumental in keeping a focus on transitioning data or making it accessible in certain ways to these different models. Not that every model is going to use that data or there's one Uber model to do everything. But if you're doing a force projection, you're looking at a very different level of detail than if you've decided you need to re-engine a B-52 and you're looking at what the thrust capability is. It's a very different model. And people tend to understand more of the specific computational fluid dynamics sort of models and where that may have come from. It's the extrapolation of that to very large scale force multiplication or projecting of, from a budget standpoint, what can I afford? Those are some of the more recent capabilities. But what's most effective, Tom, and what we're really focusing on at LinQuest is the ability to continue to access that data throughout the life cycle and keep that single source of authoritative truth available to the different models so that everything stays current and accurate and you can continue to get the benefit all the way through and get the time and dollar savings that you really need to have.
LinQuest is largely positioned for defense, but won't a lot of this technology filter down into the commercial realm as well? And what are some examples of that?
It is, and I believe it's going to be accelerating. And that's actually something that we're particularly interested in, is partnering with more commercial companies. I started to mention a little bit about that. And we see that as an opportunity for the future. I think one of the most important things, Tom, that we're trying to do is market this digital engineering as something that doesn't have to be so heavy. Sometimes when you talk about it and it seems like, I can do almost everything, but when you look at it in a national security space market, I mean, there's so much that's being done. And maybe you're just a commercial company with a very single focused business objective. And it's like, I'm not sure I really need all that. It seems kind of heavy and expensive. Well, in the aggregate, it might seem that way, but really the challenge is to look at it again from the problem. Bring in folks like LinQuest who have experience within the challenge of the problems that you have. And let's tailor a solution for the problem that you're facing. And it can be a very light lift. And in the end, it's going to save dollars of money, particularly if you're trying to get investment funding, which is becoming harder these days. If you're trying to get hundreds of millions or billions of dollars for a large constellation, and you're just using PowerPoint slides to try to describe what you're doing, it's not going to be very effective. Or I have maybe one test satellite, but how do you know the business case is going to close? There are a lot of digital engineering tools that we've been talking about that can provide what that beta experience would be to really get a lot more fidelity to the financial projections, the performance, the risk reduction, and the cost associated with it. And that's going to, I think, help a lot of the commercial companies.
When you talk about cost, is it helpful that you're working sometimes under government contracts that maybe a private company wouldn't have the ability to pay for the kind of research that you're able to do for a defense company, and then make that technology more readily available in the commercial realm?
I think that's true in some cases, Tom, but what we're finding, and I'm really glad to see, is the Department of Defense is much more willing and eager to adopt commercial technologies as well. So I think it's really a two-way street these days, and both markets are able to leverage the other. There's been a huge pivot in the government relative to 5G technology simply because of the enormous amount of money that's being invested in it worldwide. Department of Defense can't match that. So it's like, well, let's get on the bandwagon, take the best of it, and then add some additional layers of security where appropriate. The same can work in reverse, where there's been defense-funded technologies that are available now for commercial companies. And what's nice about what LinQuest has done, we've got a foot in both camps, and we're able to be one of those trusted agents to work with both government and industry.
So the commercial off-the-shelf technology is a big part of your business model as well as the defense departments.
Absolutely. And it has to be, just because the cost of everything. But as you were mentioning in some of your previous questions, there are always security issues associated with that, and you can't always just take it right out of the box. But again, that's where some of our expertise comes from, and we're trying to help our customers take the best of what's available commercially and add additional layers of protection or defense or security to it as appropriate, but not make it so constraining that you lose the benefit. And that's, again, part of the challenge of all of this. Is it's always a large risk equation in that balance. And the equation is always changing because the threat's always changing.
Eric, we are just about out of time. Hard to believe, because these interviews always go so quickly when I talk with interesting people. But I want to ask you the same question we ask all of our guests on the Ex Terra podcast, and that's to look out on about a 10 to 15 year horizon in space commerce, and tell me how LinQuest fits into that equation.
Well, I'll tell you, I don't know precisely, but I'm sure we will be. One of the fun jobs I have as the CTIO is to look into the future with some of my team, and we chart out about 10 years of sort of what the research is going to be talking about. We also have policymakers who are looking even beyond that with some of our government customers. It's an exciting future. There certainly are threats and challenges that are out there, but I think our best days are ahead of us. I'm really excited that LinQuest is a big part of it. And we definitely see more and more confluence of the government and industry partnership going forward, and the interdependence. And I think some of the challenges that we're facing right now, we'll find ways of solving some of this congestion and contention over time. There'll be some new problems that come along, but I think we're going to be up to the challenge, and I'm excited to be where we are.
Well, no less a philosopher than Elon Musk said, space is hard. And I think we're all proving that pretty much every day. Eric, thank you very much for your time. I appreciate it. And it's been a pleasure talking with you.
Tom, the pleasure was mine. Thank you for offering the opportunity for me to be here today, and hope we can do it again at some point.
I'll count on that. I've got your number. I actually have Nick's information, so we know how to get to you. So we'll be sure to be in touch. Eric Spittle is Chief Technology and Innovation Officer of LinQuest Corporation. And that is going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, and many other popular podcasting platforms. Be sure to click on subscribe so you don't miss an episode of the podcast or any of our other videos. You can also get daily space commerce news at xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on Twitter at xterrajsc. Until next time, I'm Tom Patton. Thanks for joining us.